All right, great. Okay, so I'm here to present.
Either way.
Okay, yeah, I'll just leave it here and then. Okay. Here to present Bitcoin token. So you all showed up here because I promised a smart contract engine for Bitcoin. So now everybody's like sort of disappointed after sentence one, but you know, wait for it. I think it's actually pretty cool. So quick overview of what we're going to talk about today is I'm going to sort of review some existing work about like how people implement tokens in Bitcoin today. Okay. Then I'm going to like ask the question, you know, is there, you know, anything wrong with this implementation? And like, if so, yes. And, you know, just the fact that I'm working on this means that I do think that something's wrong with how tokens are built. So I'm going to propose some improvements here. And then at the end of the talk, there's going to be a quick demo. Okay. So jumping right in. So you're all extremely technical. So what's the most technical explanation for what a token is? You know, you can think of a token as just a jar of digital marbles. Okay, you can own these marbles, you can trade them with your friends, you can send them to your friends, and then, you know, marbles come in all different sorts of shapes and sizes. You know, some of them are the same, like these white ones here, and it only depends on like how many of them you have. The other ones are all different. Okay, so what's the like slightly more technical explanation for what a token is? Okay, so let's forget about all decentralization and stuff and just think about how would you implement a token on just one machine. And in this case, it's actually pretty simple. All you do is just a database table. It's two columns. One contains sort of the IDs of the users, and the other one contains sort of their balance in tokens. Okay, and so in addition to this database table, we also have this integrity constraint. Okay, and so for example, in this case of a like fungible token where sort of balances are numbers, the integrity constraint would say that like the number of tokens in existence must remain constant throughout the operation of the token. Okay, so in order to prevent people to create tokens out of thin air. But then, like I said, there's many different kinds of tokens, okay? And then in your database implementation, you know, a different kind of token will be one where all the marbles are distinguishable, okay? And so if you want to keep track of that in the database, you can't just use a number. You have to use like a list of names or identifiers for all these kinds of tokens. And of course, if I change sort of the database, the type of the balance column, I also have to adjust my integrity constraint there a little bit, okay? So then the integrity constraint will say something like the set of tokens that exists, remains the same, under all the database updates. Okay, and then so this is just a data structure, but the question is also what can we do with tokens? And there's like 3 basic operations here. And so I can issue a new token, I can send a token to a different user, and specify a quantity there, and I can check the balance of. Okay. So what's the sort of basic problem that we have to solve if we don't want to implement this on just one computer, but like now in a decentralized network where everybody trusts each other? So the big problem is that people might want to try to create tokens out of thin air. Okay, so basically they're spending 1 token, 2 out of them. The point of these tokens is value, and if you can just sort of increase the supply indefinitely, your price is going to go to 0, so nothing has value there. So sort of to make sure that they have value, you have to ensure that tokens are not created out of thin air. And so this sounds very similar to the double spending problem in Bitcoin, but it's a much simpler problem, okay? Because Bitcoin had to solve this problem from scratch, whereas these token solutions can sort of make use of the distributed consensus provided by an underlying blockchain. Okay? Okay, so now how are tokens built today? And so I'm going to try to give sort of a very general explanation for like most token standards work on Bitcoin today. There's many different competing standards, and but most of them actually rely on pretty much the same principles. So how could we do something like this in Bitcoin? So like I said, you have to do these 3 different things. You have to be able to issue a token, and also be able to sort of securely receive a token and make sure that like nobody scams you and stuff. Okay, so let's walk just through it. So to issue a token, what people usually do in Bitcoin is they just broadcast a transaction that's called the token issuance transaction, and it must sort of comply with sort of a certain standard. Okay, and then what people do is they just add into this Bitcoin transaction some metadata that contains important information about the coin. Okay, so like in many examples, like your name there, you can specify the supply, and usually you always have to specify which standard you're using, because otherwise nobody knows what's going on pretty much. Okay, and then there's many different ways you can add metadata to Bitcoin transactions. Nowadays, everybody seems to converge towards using op return. I actually don't think that that's the best idea, but it doesn't matter. So broadly speaking, to issue a new token, you broadcast a transaction that has sort of metadata embedded there that describes the token. Okay, and then now to transfer a token from one user to another, it's again actually pretty simple. All sort of that the sending user needs to do is broadcast a Bitcoin transaction that specifies how the tokens flow from input to output. Okay, and then like all of these different token standards have all defined different ways of specifying these flows. And now for this talk, I've come up with another ad hoc way to do this, and you can see it there. Just to make this a little bit easier to read, what it kind of says is like the inputs, sort of the first input contains green tokens, and 20 green tokens. The second input 150 orange tokens, and the third input sort of consumes 50 green tokens. Okay, and then sort of the second line here specifies how they flow to the outputs, and I mean you can all read like all the green tokens go to Alice in the first output, and all the orange tokens go to Dave in the second output. Okay, so the hard part about building tokens is securely accepting tokens. This is the point where you sort of have to check this integrity constraint and make sure that the token that you're receiving is actually a valid token according to the standard. And there's different ways to do this, and there's basically two basic approaches there. The first is have all the Bitcoin miners sort of ensure that like no tokens don't get created out of thin air. Okay, and so there's been this proposal called OP Group that has been discussed in Bitcoin Cash, and it's a new opcode for the Bitcoin scripting language that will specify exactly how tokens flow from inputs to outputs. But since I mean, this is something that doesn't exist in Bitcoin right now, and so the way to do it in Bitcoin as it exists currently is the idea is just like if I get sent a token, it's my responsibility to check that I don't get scammed. Okay, and the nice thing is that you can actually do this in Bitcoin. So in this approach taken by, for example, Colored Coin and Omni, and actually pretty much all tokens that are currently existing. Okay, so let's look into this a little bit more detail. Accept the token. What do I need to do? I need to monitor the blockchain and to sort of notice when I get a new token that I can spend. Okay, so in this example that I'm doing here, so I found this unspent output on the blockchain, and it says down there Clemens gets 2 tokens. So this is like a token that I can spend. So I'm very interested in this token, but I still have to make sure that I'm not getting scammed here. Okay, and sort of to check that this is sort of a valid token, I need to find all the upstream token transitions that sort of are pretty much sort of the history of this token. Okay, every time this token has changed hands, I must make sure that everything was fine. So what I do is I query the blockchain, and I find all upstream Bitcoin transactions, sort of all the sort of token-bearing ones, and until I finally hit sort of the token issuance transaction, okay, that I explained in step number 1. Okay, and then once I've sort of completed step number 2 here, I need to sort of, now I can start to check whether this is a valid token or not. Okay, and what a valid token is what is mostly specified in these token standards. Okay. So now if you look at a token standard, they all pretty much have the same form. They always start with an intro, just like every document, and then sort of followed by a series of definitions. The first one's usually sort of the definition of what's a valid sort of issuance transaction that just specifies all the forms and the encodings that need to be there. Then if this is like a some token standard that supports minting new tokens, then there's also a definition of what's a valid minting transaction, and then usually what follows is like this sort of lengthy list of different kinds of token transfers that the standard supports. Okay, so let's just walk through this example. What we do here. So I found all the relevant transactions on the Bitcoin blockchain. So I start now verifying top down. So first I compare the issuance transaction up there with the issuance transaction definition in the token standard, okay? And if sort of it values to true, if that validates, I say, okay, issuance was done correctly, that's fine. Now I have to look at all the token transfer transactions that are down here, always compare them with the token transfer definition and see that they all check out, okay? And so in this example, let's just see that they all check out, and I have to do it top down like this because sort of the validity of a token is always kind of recursively defined in terms of the validity of all its ancestors, right? So token's valid if like, that one transfer is okay and all previous ones were okay as well. Okay, so let's see what happens if someone cheats. Okay, so I make an example here where here, sort of Carol broadcasts a transaction, creates 51 tokens out of 50 tokens. Okay, and that's exactly the case that we wanted to prevent, and that's exactly what sort of this transfer definition will tell you not to do. Okay, so now if I find this invalid transaction, what usually happens is it invalidates all sort of downstream transactions. Okay, so as soon as I found this bad token transfer, I can mark all downstream token transfers as invalid. But what's actually important here is that, like, you know, this red guy there sort of got invalidated, and everything downstream from that transaction, like starting from the point where someone cheated, everything gets invalidated. But the other users, you know, Bob here, you know, still happy with his transfer. He can still spend these 150 tokens somewhere else because he didn't cheat and nobody in his history has cheated. Okay. So what's wrong with this? Actually, this looks kind of cool in my opinion, but also in my opinion, something must be wrong. Okay, and so why must something be wrong? So you just look at the history of tokens. So tokens got invented in Bitcoin, on Bitcoin in 2012. Okay, that's a long time ago, and tokens like this, you know, Mastercoin and you know, now called Omni and whatnot, have been operational for a long time and, you know, securely without bugs, so it can't be that bad. Okay, but then what happened in, you know, 2015, Ethereum gets released. Okay, and now the ICO craze, you know, kicks off, and everybody launches token all the time, but everybody uses Ethereum. So what happened here, you know, Bitcoin had like a head start of 3 years, but still Ethereum sort of, you know, just won over the whole field. So there must be a better way to build tokens on Bitcoin. Okay, so and then, like, this is just now my opinion, what might be wrong here. So there's different things. So first of all, I'm not a big fan of this use of the op return statement. It's just, I will talk about this in detail. It's a complicated way to encode things, and there's a much more natural way to use Bitcoin transaction, what's there already to encode stuff more nicely. But that's kind of my weakest argument a little bit. Okay? My strongest point why I think this stuff is wrong is because all these token standards are sort of can express only, like, you know, a very small number of smart contracts. Okay, and these smart contracts are usually hard-coded in the standard. I'll tell you more about that. And so every single token standard that has been proposed in Bitcoin today sort of supports less than 20 smart contracts, okay? Whereas you have Ethereum, which supports an infinite number of smart contracts, okay? And, you know, that's kind of cooler. And so that's my second point. And the third point is there's, I think, a big scalability issue with the way we build tokens. This gets brushed aside a little bit, but I think in practice, in certain applications, it's going to be a big problem. Okay, so let me just walk you through these 3 points in detail here a little bit. Okay, my problem with op return is that people sort of have to encode this token flow in the op return statement, but the information that you find there is absolutely worthless if you don't have access to the standard. Okay, and so I've actually been kind of nice here and picked like a sort of a readable format here, but in reality, the people who define the tokens, their goal was to squeeze the maximum amount of information into the minimal amount of bits, and so that's, you know, that's how sort of token transfer instructions look, and I think this is actually copied from the colored coins protocol, right? And so now you're asking the programmer to kind of use this programming language, and I just don't think that's the right way to do it. And yes, please.
Is it okay to ask?
Yes, please, everybody. Yeah.
So in this op return specification for coins, it's not the case that the definition contains like the data structure of op returns that you parse it. It's
yeah, I mean, yeah, you kind of you do parse this, and it will get parsed into something like this.
But it's not part of the like issuance definition.
It's not part of the issuance transition. Did you look at my slides in advance? No, I'm kidding. No, very good comment. And so to understand what this means, you really have to look at, you can't find this information on the blockchain, okay? So you have to find the standards document. And like the blockchain archaeologist 1,000 years from now will find this information in the blockchain and have no idea what it means, just because it's worthless information. And like, I don't understand, like the goal was to save space on the blockchain, and really we're putting this information there that nobody can ever read. So to me, that's also just a way of wasting space. So the way that I do this is I just encode my metadata in the output scripts themselves. Okay? And it's very easy to do this. You take your standard output script and you just push data to the stack and pop it off immediately afterwards. So the miners don't even notice. You just push something in and you pop it off immediately afterwards. But the difference is we don't have to assign meaning to the data that's there. Okay? The meaning arises from how it works. Yeah? So how does this work? Okay, so now we find this transaction on the blockchain. We see there's just the words green and 70 here and orange and 150 here. Okay, but we also know that someone signed these transactions and broadcast them to the blockchain. Okay, so Alice, Bob, and Carol all signed these messages. Okay, so you know, there's lots of talk about how do we get data into the blockchain. No, this is a way to get data into the blockchain. I produce an output, I sign it, and then everybody knows by the functionality that I signed this statement. If I make a statement, this guy's an idiot, I sign it, everybody is going to know that I said it and when I said it. And I don't need like a separate standard document that explains that to me, because it just sort of arises from how Bitcoin works. I think that's a better way to do it. And then, what do these outputs mean? Okay? So the outputs, officially the UTXO set of Bitcoin is sort of the mutable state of the blockchain. Okay, that's sort of the current state of the blockchain that can be updated. All the spent outputs is the log of everything that happened in the past. Okay, so but a UTXO is always like, it just means you're part of the current state. Okay, so if I find this output, I know that, green 70 is part of the current state, and Alice, Bob, and Carol thought it's important to write this down today. Okay, but then what does it mean that Alice can spend that output? It means that Alice can update that data. Okay, so that's like a notion of data ownership. Alice kind of knows this data now, and Alice is in charge of, is allowed to update it. Okay, so I'm saying just by encoding data in the transactions themselves, there's sort of lots of semantics attached there that we don't have to specify in separate documents. It just arises from how it works. I think that's just a better, cleaner way to do it. Okay, and of course everything that I can do here can be encoded in an op-return output, and that's absolutely true. But that's just like saying, okay, we can just use JavaScript, and as variable names, we're only going to use numbers. Okay, you can program everything like that. It's just horrible to program that way. And if you want to look at Bitcoin like a programming language, I think it's important that we sort of encode data as cleanly as we can. Okay, but that's my least strongest point. So my biggest issue is currently this thing, just these standards. And it partially has to do with the fact that, like, preparing for this talk, and I had to read all these standards, and it's not fun. They're very, very long. Omni protocol is 100 pages, and they're just not meant for human consumption. Okay, and it's not that they're badly written or that the authors are stupid. That's not at all the case. They're very smart, but it's just like the content that you want to write down is just not suited for human consumption. So you read this document and it says, byte number 3 means this and has to be 1 if this is the case. Like this, nobody can read this stuff. Okay, and it's just very, very complicated. Okay, so number one is it's very hard to read, and being hard to read just means very few people will read it. So I'm going to assume that like I think at most a handful of people have read the entire Omni specification. Okay, and so if very few people read your standards document, it's very unlikely that they will find little bugs in there. Okay, so it's really makes everything less secure. Okay, and the second problem is also it's hard to implement. So in my opinion, there's no harsher punishment for a programmer than having to re-implement one of these standards, because you're going to spend like months sitting there parsing every single line in this text-written document and turning it into code. That's just something horrible to do. And there's no way that if someone does this for 100 pages, they're not going to make one little mistake. Okay, so I would bet that none of the Omni implementation. I don't want to like harp on Omni too much. Okay, this is the case for all of the other ones as well. Okay, I'm sure that they all are not 100% sort of standards compliant. And then you have two different, the only reason you have a standard is you want to have multiple implementations. Now you have two different implementations with two different kinds of bugs, and then bad things really happen. So I don't think that's good at all. And sort of the most important thing here is that there's, in this general approach that everybody's using today, there is this inherent trade-off between simplicity and expressivity, okay? And let me tell you what I mean by this, okay? So think of the space of all tokens. Okay, I told you in the beginning, a token is a database table with an integrity constraint. Okay, so when I mean all tokens, I mean all database tables with all conceivable sort of integrity constraints. That's an extremely large class of smart contracts, pretty much. Okay, and then if we look at what these transfer definitions really mean, these transfer definitions really map to like one specific token. Okay, you have one transfer definition for a fungible token. That's like the ERC20 token, ERC20 token contract in Ethereum. You have one for non-fungible tokens. So each of these little transfer definitions really correspond to one token, one dot on my infinite pane of all tokens. Okay, so now everybody sets out to build a better token contract. Okay, two directions you can go. Okay, either you say we're going to do the simplest possible standard, but really what they're just doing is they're taking away these transferred transfer definitions. Okay? Just to give you a feel for this, Omni contains, I think, 13 transfer definitions, and then there's another 13 of them that are, or like more or less, that are sort of proposed for the future. Okay, so if I want to get I have a new idea for a token, I have to get back in line after 13 other people that have to be implemented before me. That's that's just never going to work. Okay, so but then there's sort of the other side where you say, okay, we're going to make a very simple standard, one that people actually read and where they will find bugs and where implementations can be made that are compliant. But sort of that comes at the cost of just reducing the stuff that you can express even more. Okay, so you're sort of now we're only supporting one smart contract. Okay, maybe I have the shortest standards definition, but I can only do one smart contract. So that can be awesome. And then sort of the other approach is we keep adding more transfer definitions here, and what happens is we add like this little dot. We can cover one more little smart contract in this infinite class of smart contracts, and then we can't cover this is not going to work. Okay, we can't cover everything that way. Okay, so just to do this a little more, here's like the business school side of this. We have simplicity on the x-axis, expressivity on the y-axis. Some standards, I'm not going to name names, are neither simple nor expressive. Forget about those. We have a bunch of them that are very simple, but only support very few use cases. And then we have sort of, these are actually, in my opinion, the best ones right now. Those that are very, very complicated to read and to use and to implement. And then they can express, a handful of smart contracts at least. So that's actually better. But, can we get, any better than this? Yeah? And I think we can. And the reason I believe this is because we have Ethereum. Okay? Ethereum, if you want to learn it, it's actually quite simple. Okay? And it's also fun because you're learning a programming language, but Ethereum really only consists of like 10 constructs that you have to understand, really. Okay? It's quite simple to understand. I'm going to say Ethereum is like as easy to learn as like all of these existing token standards. But it's like way, way, way more expressive, okay? And actually, like Ethereum, I'm being pretty kind to our token standard here. Ethereum is way off the chart because like infinite number of smart contracts. There's like 13, okay? There's a big difference in expressiveness between Bitcoin token. So what I'm going to try and do is create a Bitcoin token standard that's like very simple, like the simple ones, but also much more expressive, okay? And so actually, what I don't know is like how the expressiveness of my thing currently compares to Ethereum, but we can do like an infinite class of smart contracts. We can do many different things here. Okay, so, okay, and I also wanted to talk about like scalability concerns. Yeah? Okay, my scalability concerns are about like, and this actually gets brushed over in many of these token definitions. They're like, okay, yeah, like most cases we can build a light client, it's just gonna work. But here's the bad thing that can happen, okay? I find this token transfer definition where I can spend the token. Okay, and so I do my recursive thing and I find all the ancestors. I find 2 answers. That's fine. They have 4 ancestors. Okay, and that's just like if these transactions have like sort of 2 incoming edges, sort of 2 inputs. Okay, I get like an exponential explosion in the number of work that I have to do. Okay, and that's just never going to fly. And so I talked to a friend of mine at Google about this, and he was immediately, we have to work with this. Okay, there's no way this can work in practice if we have like exponential runtime in the age of a token. That's insane. Okay, and it really like all your entire fungibility goes completely out of the window. You get 1 token, check 3 transactions, you're fine, you got it. Get the next token. You have to verify stuff for 3 hours. Okay, and I think this actually works in applications, in B2B applications where you care about throughput more than latency, because, and this is probably why we know Tether works. But in consumer-facing applications, you care about latency. Okay, if you're doing a game and someone's trading with you, you don't want like to wait an hour to get your score or something like this. Okay, so I think this is a big problem. Okay, so now that I've like complained about existing standards, let's see if I can contribute something here. And I also don't want to sound like too negative here. I actually think like the invention of tokens on Bitcoin is amazing. And the fact that it happened in 2012 is incredible. And it's like very brave and smart people did this kind of stuff. But now, it's 6 years later, so we should be able to improve on this kind of stuff. Okay, so first of all, yeah, I don't want to play this game. Okay, I'm not going to start, even like I'm the guy who had to write this standard. I would refuse to write 100 pages of boring stuff. That's like, I don't want to spend my life like this. Okay, what I want to do is be lazy, not write a long standard, and cover all possible tokens. Okay, so how do we do this? So first of all, I've argued, so this thing I'm just going to remove this from the standard that's in my mind that I haven't even written yet. And then, so now this minting transaction definition, in a sense, that's also just like, you can think of it as like just a special token transfer definition. It's just one with a different integrity constraint. It's just one where you can, create tokens out of thin air. That's what minting does. Okay, I'm going to say it's pretty much the same thing. So I'm also going to remove this. Okay, but then, so the question is, how do we come to a token standard that covers this all? Okay, so one approach is to have an infinite length token standard. It's unpractical. But really what we need to do is, at the end of the day, for every single point in my infinite pane here, in this orange thing, we're going to need one transfer definition. Okay, and sort of the approach that I take here is, I just trust the programmer more. Yeah, I give the programmer more power. I don't tell them how to specify stuff in detail. I let them give it to me. Okay, so in my token standard, I have a parameterizable token standard. Okay, and if you want to use my token standard, you can use this and all this, finding all the, previous transactions on the blockchain. It's going to work just like before, but you get to decide what's your definition of a valid, token transfer definition. Okay, and since like, for every dot there's one transfer definition, I can, plug in for every dot, I can plug in the transfer definition in my standard and like cover that dot. Okay, so just by this simple trick of having the token standard be parameterizable by the definition of the token transfer transaction, I can cover all possible tokens, which is an insanely large class of smart contract, and it's unclear whether it's equal or less to Ethereum. Okay, and then the next question is, okay, so the programmer provides who sort of provides this this token transfer definition, and I think it should be the guy who issues the token. Okay, so you issue a token, you make up your mind which transfers do I allow, and sort of you write your definition here. Okay. And so now I've said that like any user can write their token transfer definitions, and I've also complained that like all these tokens are very hard to write. Now I'm sort of proposing that we have a standard where 100 different people write 100 different definitions. That's going to be even harder to read and understand. Okay, so maybe we should have like some sort of formal language here. Okay, and so I propose that we use weak monadic second order logic with the unbounding quantifier. And so you're all engineers, I'm sure you're all familiar with this stuff, so raise your hand if you've heard of this stuff. Okay, that's a bad joke. Of course, we're not going to do that. What we're going to do is we're going to specify them in JavaScript. Okay, so everybody knows JavaScript, and essentially what I'm proposing is, write smart contracts for Bitcoin in JavaScript. Everybody knows and loves JavaScript, okay? And it doesn't have to be JavaScript, it can be any programming language. Okay, the standard is very generic. Okay. Then, okay, so how do we define transfers, Bitcoin transfers in JavaScript? Okay, so let's look at this example of the ERC20 token. Okay, what you have to do is you have to implement in JavaScript a function that inputs the JSON representation of the transaction and outputs a Boolean. That's it. That's all that the standard says. Okay, plug in your definition here. It has to be a function that inputs a JSON representation of a transaction, outputs a Boolean. I don't care about the rest. Okay, you can plug in there whatever you want. Okay, so let me show you a few examples. So okay, to be precise, we're plugging in the transaction and the UTXOs that it's currently spending, because you need to know that to validate the thing. Okay, how do we do this? I mean, we just write a simple function that we got this JSON representation of the UTXOs here that just parses this document and finds the right data and then sums it up. So you compute the sum of tokens that are sort of consumed by the inputs. Okay. And then you write, a very similar function. We just iterate the outputs of the transaction that you got input. Okay, and you compute the number of tokens that are sort of created. And you just return. You have to return a Boolean. You just return that these are the same numbers, or one should be smaller than the other, whatever. Okay, so this is a very, very simple way to define an ERC20 token in Bitcoin. Okay, and then of course you have to implement your some inputs function, some tokens function number here. Okay, I'm just going to leave this as point. And then, so any questions at this point, maybe? Please.
Sure. Don't you think actually it's kind of problematic to actually write a smart contract in JavaScript, because actually you will basically introduce more bugs? Because I feel like Solidity, there's a reason why it is as it is, because it's a domain-specific language. Because now you actually have all the other bugs that can actually add a baggage with JavaScript itself as a language.
Yeah, so I agree. I think JavaScript today can be made better than it was. So all the code that I'm writing is always like statically type check this flow, and you know I'm using like this super harsh linter by Airbnb. And you can actually get around many of the gotchas that JavaScript used to have. So JavaScript today, I'm saying, is better than 10 years ago. But still, if there are still weird corner cases that people might fall into, and if they don't want to use JavaScript, they can use any other programming language they like.
Absolutely. I mean, my point is that actually, for an experienced developer like yourself, you can use like TypeScript and Flow and like type check JavaScript and do certain things and really avoid some corner cases, right? But then we have like more web developers coming on the scene. They want to write like smart contracts, but they don't have the best practices, right, when it comes to writing like secure code. Yeah. And I think it is actually they're the ones we need to maybe worry about.
Yeah, no, I agree with that, but still, I think actually learning Flow is not as hard as it seems. Okay, and like these smart contracts, many of them will be quite short, so you can get quite some way with JavaScript and Flow. But then if it's so, this is also just step one. Okay, eventually I want to like create a better smart contract language that will be much fewer corner cases to worry about. But like in step one, this is sort of for me. I'm working on this for 4 months now. This is sort of the fastest way for me to make progress is, okay, right now we'll write these contracts in JavaScript, and eventually we might move on to a different language. Yeah.
I'm confused. What are the contracts compiled to?
They compile to nothing.
They run.
Yeah. So I mean, what happens is, so I'm building sort of the smart token standard and the reference implementation. Okay. So and then going back to this link here. Okay. Well, actually, I should have on the other side. So this is all. No, it's totally fine. Yeah. So this is all sort of taken care of by the reference implementation. Okay. The reference implementation, go ahead and like download all these little things. But then when you go down, when you check these transactions, you just run that JavaScript. I find that definition, and I just run. Whatever function you give me, I run, and I'm going to say, it's, checks out if it values true, and it doesn't check out if it values. Yeah?
So you're building a runtime?
I think that's what a runtime is, then. Yeah. Right. So actually, I have also slides about what we just talked about. Okay. Where were we?
This token definition runs off-chain. I think that's what you was maybe.
No, well, everything, all these token definitions usually, most of them work on chain, where sort of if you want to send a token to another person, you broadcast the transaction to the blockchain. And all these trees that are shown here, these are all transactions that are like committed to the blockchain.
The verification.
Yeah. Okay, so I had this thing, and this is my parameter standard issue, plugs it in. Okay, and then we talked about the fact that we're not going to do it in this stuff. We're going to use JavaScript. We got these examples here. Okay, so ERC20 token, I think we did. And like this is, ERC 721 token. This is like the non-fungible token standard. This was used for the CryptoKitties, I think. Okay, and your function is a little bit longer, but it's actually not much more complicated. Okay, all you have to do is you have to like deal with sets and set equality and just disjointness and stuff. It's still pretty easy sort of to write these kind of things. Okay, and then if you want to sort of, my opinion is like we haven't yet discovered the killer application for smart contracts. Okay, so the smart contracts that will be developed in the next 20 years will be way more awesome than everything we have right now. Okay, and so you can just if you're the person to invent that smart contract, congratulations, you're now rich, and you can just very easily sort of encode it in this thing. Okay, and you can put as complex code in there as you like, as simple code in there as you like, whatever you want to do. Okay. Okay, and the next question is like, where do we store these transfer definitions? Okay, and you think, okay, so maybe we use a web server. Okay, and then, web server, the problem is, okay, so now some bad guy issues a new ERC20 token. It's like, the well-understood program that everybody knows and stores it on the web server, and launches the token, raises $50 million in 3 days, and after 3 days he changes the web server to say, okay, ERC20 token is okay, but another transfer that's okay is send everything to me. He just scams everybody. Okay, and so we can't store these smart contracts on a sort of mutable device like a web server because it's entirely insecure. Okay, we need to store it in some place that we're guaranteed that it never changes. Okay, and that it never changes, and that And that's, we can always find it at the same place. Okay, so does anybody know a storage device with these properties? What? No, but I think you said it. Blockchain, that's it. Okay, I'm going to store it on the blockchain. Yeah, that's what Ethereum does. Okay, they store their smart contracts on the blockchain. We'll store our, JavaScript, Go, whatever you want, smart contracts on the blockchain. Okay, and more specifically in the issuance transaction. Okay, and now I have it coming back to your question here. How this all kind of fits together a little bit. Okay, I have my parameterizable token standard, and I don't know anything about this token. Okay, all that happens is I find this transaction where I get 100 tokens. Okay, so I don't know anything else. But so now I use sort of my reference implementation, or I do it by hands. I find all my upstream transactions. Okay, and there in the issuance transaction, I find my transfer transaction definition. Okay, just a little bit of JavaScript code. Okay, and then when other than that, everything works just like in the previous token standards. Okay, so I still I find in my issuance transaction, the standard we're using is the Bitcoin token standard. So I find the Bitcoin tokens and I check this issuance transaction definition, and in this example I'm going to say it checks out. Okay, but then if I have to sort of validate these downstream transactions, I always validate them against a sort of transfer definition that's stored in the original output, in the output of the issuance transaction. Okay, and so this is how I can sort of accept tokens using the simple token standard. Okay, and okay, so that was sort of my attack to give us more expressivity, and like I said, it's can sort of it's very, very expressive. So in fact, like every existing token standard on Bitcoin, can be implemented in this thing. And so if you're working on your token implementation, you're lazy, write the JavaScript function, use my code, and you're going to be done quickly. Okay. And okay, so now back to the scalability problem. So I talked about it like scalability, like issuing a token is super quick. Okay, all I do is I build a transaction, send it to the blockchain, and I'm going to say it's constant time. Sending a token super quick, I just build a transaction, broadcast to the blockchain, done. Receiving a token, we have this horrible runtime, exponential in the token age. And so I talked about why this is really, really horrible. Okay, but then sort of the first idea here is, you could call it just like, don't be an idiot, or, more technically use memorization. And it just means like, store stuff that you've looked at, okay? Once if you trust yourself, you've validated yesterday that, this is a valid, transfer transaction, and you know that, Bitcoin's immutable, it can't change if there's enough confirmation and stuff. You don't have to check that again. Okay, so the idea is every time you check that like some transaction is valid, you store that in your database. And actually you don't have to store the entire database, you only have to store the very, very short transaction ID. Okay? So, and like the advantage, this is very cool. So now I find this new token here. And so instead of having sort of to revalidate all this potentially exponentially large thing, I just look into my database. Okay, so that's really quickly. And maybe I'm even lucky, and sort of the other thing also just has like this short history, and I can accept tokens really efficiently. But unfortunately, this is no guarantee at all. Okay, so this does nothing for worst case complexity. If I'm just unlucky, I keep hitting these really, really expensive things. Okay, and this is where this thing about like latency versus throughput comes into play. So probably like on average, it's relatively, on average it might work, and that's maybe why Tether works. But like if you're interested in latency and worst case performance, you've won nothing here. Okay, and this is actually a bit of a problem. And when I started to understand this, I got a little bit depressed and I thought, well, fuck, picked the wrong project here. And I talked with my Google friend, and he depressed me even more. And then, well, that's bad. And then there's actually a paper that claims we can use zero-knowledge proofs to somehow, the idea would be that if I receive a token, the sender also sends me a proof that, that this is a valid token. Okay, and so, I mean, the paper was, a little bit light on detail, so I'm not sure I can verify that. And also, man, zero-knowledge proofs, I wanted to launch something soon, now I have to learn about zero-knowledge proofs. That seems tons of work, so I want to look for, something more practical. And okay, so what I'm just thinking, JavaScript, you can write programs in JavaScript that don't terminate. Worst case behavior of JavaScript is infinite. Yes, please.
The previous slide.
Yeah.
Are each and every one of those transactions running off of a different contract, or?
No, each of these transactions is sort of one transfer in the same contract. Okay, so think of the ERC20 token. There's like a bunch of tokens. They're all sort of stored in the unspent outputs here. And when you own one of these unspent outputs, you can send it to someone else by building a transaction and sending it to someone else.
So, what is the difference between the way you're looking at this versus what's here?
So the big difference between this and Ethereum is in Ethereum, the miners take care of all this. Okay, so all the smart contracts are sort of evaluated by every miner, and you as a user don't have to do anything. Okay, if it's on the blockchain in Ethereum, you're secure that miners have checked that this is a valid token. But since miners are not aware of these tokens in Bitcoin, and these standards all sort of work around Bitcoin a little bit, you have to check it yourself. Okay, it's a great question. I will actually talk about the same point in a bit as well. Okay, so we can get unlucky, but okay, so let's see. So maybe just like in JavaScript, worst case performance is really bad, but still JavaScript is a very useful tool, right? And just because there's many interesting relevant use cases that can be sort of solved efficiently with JavaScript. Okay, even if you can't solve everything, worst case, not so bad. So this is just my thought process. Let's just think of important use cases for tokens. Okay, and just the simplest and most important use case I can think of is just like streaming. Okay, so Alice buys their Wi-Fi from Bob. She pays with tokens and sends him token like one directional every 10 minutes, just token, just in one direction. Okay, that's pretty much the simplest thing I can imagine. Okay, so how would this work with everything exactly like I explained before, plus this memorization? Okay, so Alice owns 10 tokens here, and Alice has already verified, let's say. Okay, and now Alice sends one token to Bob. Okay, so Alice broadcasts this transaction here with two outputs, saying that Bob now has one token and Alice has 9 tokens now. Okay, and the operator is there to store everything. And since Alice broadcasts it and she trusts herself, she just puts this in her database immediately. Okay, and then Bob comes along and finds this transaction on the blockchain and does the usual game. Okay, so he goes back to the issuance transaction, verifies everything is valid. Okay, and then like top down, he starts adding this guy to his database, and in the next step he adds like this current transaction to the database. Okay, then Alice sends the second token to Bob. Okay, and now Alice puts it into her database immediately. Bob now finds that output and traces back, but due to the fact that it's just streaming just one direction, he had already sort of just seen this sort of previous transaction, and he just sort of has to hit the database like in constant time again, and can accept this transfer immediately. Okay, all that she has to do is sort of parse this one transaction and hit her database one time. Okay, so that's like an extremely efficient way to do to send tokens in one direction. Okay, and they can keep doing this for a long time. Okay, so now it's a little bit less depressing. At least we found one use case that we can find we can do efficiently. Okay, but maybe it gets better. Let's look at other use cases. Okay, another sort of very, very simple use case would be I call it the ping pong use case. Maybe it's the casino use case. I don't know. Where two guys just send a token back and forth all the time. Yes, it's a bit silly, but wait and see. Okay, so can we do ping pong use case efficiently is the question. So how does it work? Okay, so Alice first has 20 tokens, then Alice sends 10 tokens to Bob. Alice now has 10 tokens. Okay, so Alice just sent something to Bob. Now Bob finds this, stores the stuff in his database, and sends a token to Alice. Okay, I made a little mistake here. This should be 1, but who cares? And okay, so Bob sends one transaction back to Alice. Bob puts this into his database because he trusts himself, and now Alice sort of has to verify. But again, we see the same behavior like before. Alice already has all the upstream transactions in her database. Okay, and so we can go on. If we now sort of Alice sends a token back to Bob, Alice trusts herself. Bob already has the upstream transaction in the database. So the ping pong use case we can do efficiently as well. Okay, that's better. So let's see. So what about sort of combinations of ping pong and streaming? Okay, so let's say these guys do streaming, 2 rounds. Okay, so here Alice sends 2 tokens to Bob. Bob now has 2 unspent outputs with 1. Alice has 8 tokens. And now say they want to reverse, sort of switch to ping pong mode, where now Bob sends something to Alice, and say Bob wants to send two transactions to Alice. What she does is he just builds the obvious transaction, spending sort of these outputs, from the stream to Alice. And, when Alice finds this, again, we have the property where all these sort of upstream transactions are already in Alice's database, okay? So what this tells us is that like any combination of streaming and ping pong can be done in constant time to receive the token, which is awesome. And in fact, actually, if you think of it, every single token exchange that just involves two parties is like some combination of ping pong and streaming, okay? So what this kind of shows, if you're like a little bit careful with how you build your transactions, you can actually do all protocols between two people, very efficiently. Okay, and so how does this help us build, services on top of Bitcoin? Okay, so if you're operating a service, you're one of these hubs here, and you have users, and what you need to maintain is, pretty much one TXID for each of your users. Okay, and since all these TXIDs are like so small, you can fit like 31 million of them into 1 gigabyte. Okay, so you can operate a service with, where you have 31 million users, with just one gigabyte. Okay, you can afford more than 1 gigabyte this day. So this scales like way more than the underlying blockchain. Okay, so this isn't like the bottleneck anymore. And if you don't like centralized stuff, decentralized version is the same way. Okay, now all the users, of course, also like in this previous picture here. So these centralized nodes need to maintain like I don't know how many there are, 7. 7 streams, and each of the users just has 1 stream, and this guy there has 2 streams. Okay, but then if you want to do the decentralized version of this, now all the users have like more. Have to store more than just 1 TXID, but still sort of they can join sort of some sort of decentralized social network. There's 31 million people that they send tokens back and forth with, okay, just in 1 gigabyte, okay, and nobody sends tokens to 31 million people, okay, so this is something that can be done extremely efficiently. So, okay, so what does this, and this also comes back to, I think, your previous question. So what are sort of the implications for scalability? Okay, so like mentioned, like the big difference between Bitcoin and Ethereum is that like in Ethereum, the miners check all the smart contracts. Okay, so that's cool for the user because they don't have to validate anything. But it also, of course, on the other hand, like all the miners have to validate all smart contracts. Okay, whereas sort of in Bitcoin, if we do it like in this way, Bitcoin only is sort of this hyper efficient minimal thing that just sort of provides distributed consensus, okay? And sort of the smart contracts are sort of built around this a little bit, just sort of making minimal use of this distributed consensus, okay? And the nice thing here is that like these smart contracts are only evaluated by the parties involved, okay? So I can write a smart contract where accepting a token is an NP-complete problem, right? Where you need a supercomputer to accept this token. Okay, but if everybody, who's in that token is interested in the same thing, that's going to work for these people, and nobody else has to care. Okay, if you wanted to do this in Ethereum, it'd be like insanely expensive, and people would start, complaining about like social costs and stuff like this. Okay, where maybe some rich guy can afford to run these super complicated contracts, but then kind of nobody else can use Ethereum in that time. That kind of sucks. So I think this sort of hybrid approach, where sort of, you just use Bitcoin to sort of for the distributed consensus and build stuff around it, might actually be a path that, might make Bitcoin scale much better, and at the same time support, more complicated applications than Ethereum, okay? And, disadvantages, you have to look out for your own good, okay? That's in my opinion how the world, should work. Okay, so that was my simple token standard. Its selling point is, it's simple, expressive, and scalable. It's the first contract that sort of breaks out of this problem of the trade-off between simplicity and expressivity, and it's also extremely scalable, and it's also implemented in JavaScript, so it's, it can run client-side, you can build non-custodial applications with any sort of mostly legal and regulatory advantages, and yeah, that's what it is. And now the demo, which is highly entertaining to you for the same reason that it's horrible for me, because there's like the possibility for embarrassment in the internet, but I think I should be fine. Yeah, it's cool for you, but yeah. No, actually my code is actually relatively stable now, so it should work. Okay, let's see here. Okay, so, was there a question? No? Okay. All right, let's see here. So we have, okay, what I have running here. So I have running a message server. So since I'm using non-standard contracts, I have to use a P2SH, and you can't just look at the blockchain and figure out that that's a that's a token that's relevant to you. And so instead, I'm using sort of the separate server just as a messaging server that when I send you a token, I also like send you this message. Okay, here's your token transaction, and here's sort of the pre-image to the P2SH hash. Okay, so the way P2SH works, it doesn't store the actual scripts in the blockchain, just the hashes of the scripts. Okay, and so this is my message server here. But if you're concerned about running a server, you can replace this by, it is just a messaging system. Okay, you can replace it by a decentralized messaging system if you like. And also, if you really don't like it, lobby for allowing non-standard scripts, because it's going to make Bitcoin much, much better. Okay, let's see here. So we got our trusted server running. We're going to wipe the database just for good measure. Okay, and now, of course, I don't do this by heart. I have a little script here. Let's see. Okay, we run node just with this command line flag that allows me to use a wait. Okay, here we go. Okay, now we just sort of create a new token object. Okay, returns undefined. That's okay. We're going to need a Bitcore implementation. I'm using bitcorelib or a version of bitcorelib. We need a private key to initialize the. Did this happen? No. Okay, because I didn't copy it. Oh, no. Okay, has already been declared. Okay, that's just me being stupid. Okay, so we now have a private key that we're going to need to sort of initialize this token, and we're going to need these test keys just for technical reasons. I mean, all of this is going to be much nicer. I've not spent time massaging the code for this presentation. Okay, now we want to issue a token. What we just do is we create a new token object. Okay, and we set the private key to this. This is just some thing. All that this does, it just sets the private key property in the token object. Okay, and now we can go ahead and define our token. So we're going to say token 1 dot total supply. Okay, how much supply do you guys want?
100.
100, all right. Come on, make up your minds, people here.
21 million. I want it all.
No, we're going to do 100 because that's easier to keep track of. Okay, we're going to set total supply to the thing, and we're just going to call init. That doesn't do much yet. That just sort of initializes the wallet with the private key that we plugged in there previously, and this sort of thing. But now we can do actual interesting stuff, and we can create the token. Okay, and what this guy here does is it actually creates the token issuance transaction. Okay, and it returns this key here. Where now we can go to block cipher, whatever it is, block trail, and see that like this is an actual transaction. Okay, it's unconfirmed. I just broadcasted right now, and you see. So you always have to have like these extra inputs that just pay sort of minimal Satoshi amounts. But then you have like this guy here, this P2SH address, which is sort of the token issuance transaction. Okay, and it's got encoded there how many tokens there are. Okay, and so at this point, I can already, I guess, check the balance of this token. Okay, because that's supposed to happen because I haven't defined public key 1 yet. Let's define public key 1. Okay, now I can do the same thing. I can get the balance, and I see that it's actually 100 things. And so this get balance function does the actual shebang of looking up all the upstream transactions and stuff like this. Okay, so my implementation is actually not that far away from being production ready. And mostly what I'm not doing now is like this fancy thing with storing smart contracts in the blockchain. Currently, I just have hard-coded an ERC20 token, and I'll have to rip out like this, find the piece of code to rip out that you guys will be able to store on the blockchain later. Okay, but other than that, it's actually in pretty good shape. Okay, now we want to send this token somewhere. So we create a new user, and currently it's also a token object. This will all be cleaned up. And again, we have to set a sort of, to initialize the wallet, we have to add this private key in here. And like this output, this is not my fault. I think this is Bitcore or something. Okay, and we initialize token number 2. Okay, and we have to like get the public key of token number 2. Okay, because to send stuff, we need a public key. Okay, so now we have balance. Token 1 get balance was 100. Token 2 balance, and again, 0. Okay, let's send something. How many tokens should we send here? Why do you do this? 4. Okay, let's first try. Okay, I just sent 1 by mistake, but let's see if this worked. Where's the balance thing? And up there. Okay, token 1 now should have 99 tokens, all right? And token number 2 should have 1 token. Okay, let's try this -4 thing, which I never tried, and it's probably not a good idea, but let's see if it flows. I'm sorry. Wait. Okay, -4 public key 2. Okay, I shouldn't be doing this, but okay. Okay, string must be, okay, so there's an error, that's good. Okay, but let's try something else that's bad. What? Yeah, I need like, if something goes wrong with the hex encoding. I'm storing everything in hex encoded. I don't think it's gonna be that easy. You just go on and keep torturing me here. So how do you do this? OX or shit? Or, just
0.
Okay.
Yeah, I've been hanging around here for about 4 years.
No, it has to be 30.
Yeah, it's not gonna work.
It has to be 30 bits.
Yeah, it has to be an integer. What my code does is like parse an integer into a hex, and probably it just can't parse -4 into hex. I don't know what the problem is, but you're not supposed to do that anyway. Okay, so but let's do something else that's mean, and you're able to do this. Let's send, token 1 has 99 tokens still, I think. So let's send, 100 tokens to public key 2, and syntax errors. Okay, yeah, cool. All right. Okay, now we get insufficient token funds. So that stuff already kind of works. Okay, so we got basic functionality here, but there's still more work on until I can launch this for real money, but it's not that far away, and you can help. Okay, so that didn't went too bad. All right, lost the thing. Okay. So, okay, I'm now on a new mission. My mission used to be getting paid for the work you do online. My new mission now is understanding computation in Bitcoin, which to me is absolutely fascinating. To me, the difference, maybe the way I see Bitcoin differently, I see Bitcoin as a programming language, okay? And just the means to do computations. And I want to understand how this works, and this is super exciting to me. And if you want to help me, join me, number 1. Haven't raised funds yet, so if you're an investor, get in early. You're going to get very, very rich if you invest in me. Okay. And well, if you're an intern, let me do my plugs, and I'll go in a second. Okay. If you're an intern, you want to intern with me, and you're a great computer science student, hit me up. That's my email, and come do an unpaid internship with me until I raise funds. If you're a world-class programmer, also just get in touch. I hope I'm going to have funding soon, and I want to build the best team in Bitcoin. Okay. So I'm talking with all my smartest buddies from before. I'm going to have an amazing team. If you want to work, with a great team on an exciting project in Bitcoin, get in touch. And if you want to help me with open source development, you can do that too. There's this project called Bitcoin Cash Flow. So the thing is that like JavaScript Bitcoin implementations are in really bad shape. Okay, like Bitcore uses all this prototype inheritance stuff. I'm afraid even to change things because like coded so weirdly. So I'm sort of launching this community project called Bitcoin Cash Flow. And so if the goal is just to, don't change anything, just get a clean implementation of JavaScript Bitcoin going, okay? And so like step 1 will be, introduce modern JavaScript, no more prototypic inheritance. Step 2, make it sort of compliant with, some very strict linter, okay? Because I'm actually quite a fan of linters now. And then the reason it's called cash, Bitcoin Cash Flow, is because eventually it's supposed to be statically type checked with Facebook's Flow, because I think it's insane that we have like billions of dollars resting on code that looks horrible if you look at it, okay? So you can all please help me. It's the easiest way if you want to get into Bitcoin, you want to work on the actual Bitcoin code, that's a very good way to get your feet wet, because all you have to do is be really good at JavaScript and just turning horrible JavaScript into nice JavaScript, and you will learn how Bitcoin works on the way. Okay, I'm sorry, and I'll come back to you. Thank you very much. Okay, I think he was actually first, and
So I feel like a little bit like you felt given a demo, this might be a dumb question. If the miners aren't understanding these outputs, what prevents a double spend?
The recipient, it's the responsibility of the recipient of the token to make sure it's not a double spend. Okay, so double spends can happen, and if
shouldn't one of them succeed? Like if I sent,
Yeah, well, not in this case. In this case, like the person who cheats just sort of burns his coins. And that's nothing that I invented. I think all of these coins things.
Can't I make it a double spend much later after the fact?
No, because like if a valid transfer gets sort of committed to the blockchain, you'd have to sort of spend, you'd have to do a Bitcoin double spend. Well, you could do a Bitcoin double spend if you wanted to, yeah. But then, I'm just going to, miners take care of that. Okay, so just like in Bitcoin, you can do a Bitcoin double spend, but the token double spend, the recipient will do that.
I guess I'm still not, I'll talk to you after.
Okay.
And I'll pass this down.
So quick question on the JavaScript. Were you saying that the current JavaScript wrapper for Bitcoin is in a pretty terrible shape?
Okay, so I picked the best JavaScript Bitcoin implementation I could find, and from what I could tell, it was Bitcore. Okay, so I don't want to say that Bitcore is bad because it's great and I love it and I use it all the time. I'm just saying, it needs to be updated now. So I'm saying the JavaScript Bitcore is in bad shape.
So the question that I would have is, why don't we take the C++ implementation of Bitcore and just use WebAssembly, have one code, and then we just work on the build script so that you're instead of duplicating it twice?
So first of all, I would love for this to happen, and I would even collaborate. That'd be awesome if we did it. What sort of the way my architecture works right now, I sort of have this JavaScript implementation of Bitcore, and on top of this, I have my simple token standard thing. And sometimes I need to change, adapt things in the JavaScript a little bit. For me, it'd be easier to be able to just change the JavaScript thing, because if we do it your way, I'd have to change, the C++ implementation. Recompile, which will work too. So I think either ways would be a good way to do it. We just need a better, more reliable JavaScript implementation of Bitcoin. And you're proposing a very good way to do it, and the other way would just be to clean it up.
So the transaction fees, it sounds like that would all have to come from the initial issuance or a token definition transaction and then spent up from there. Is there a good way of injecting more transaction fees?
Yeah. So it depends on how smart you are in writing. Sort of you as the user gets to decide what's a valid transfer transaction. Okay. And I would recommend that transfer transactions may have one non-token carrying input, with an arbitrary number of satoshis. So that's how you put it on. Okay, but it's not up to me to decide. It's up to the program to decide. But it's good.
Have you given much thought to how it might work in two different tokens, one transaction? I'm exchanging some number of red tokens for a number of blue tokens. How validation might have to work in that kind of scenario, making sure that both wallets, that the wallets agree that these are two different standards, right?
Yeah.
And so you could have quite a complexity.
Well, what you actually could do, just because the token standard is so general. So say there's two existing token solutions even, and more mix the two together. I can write now the third token standard that says everything, all the red tokens are valid, all the green tokens are valid, and I'm in addition also going to allow ones that mix the two in one transaction. Okay, so you could build sort of a higher level token that just sort of makes these two tokens interoperable.
So there's some simplification that can occur, because otherwise you're going to have to validate all of blue tokens to exchange them with the red tokens, even though the red chain is really short.
Yeah, so you would have to essentially sort of encode the purple tokens, and they would validate both the red tokens and the blue tokens. But it's a great question. I've never thought about this, but you can immediately do it in the open token standard. Okay, so this thing of transfer definition is just a function of inputs a transaction, outputs a boolean, is so general that you can cover in a month.
Got one right here.
Okay, sorry. Okay.
So one comment, one question. First, if you're looking for a good JavaScript implementation, you want to plug Bcoin and Bcash.
I love Bcoin. Okay, so Bcoin is actually the exception. Bcoin is beautiful. Okay, and it's it's beautiful. I don't think it's type check, but other than that, I'd be happy to use it. It's just okay. And okay, I was just used to using Bitcore as well from my previous job at yours, so I kind of gravitated towards that. But Bcoin is beautiful, and
It uses ES6, 7, and 8. So
yeah. Man, that
type of inheritance,
yeah.
async await.
Yeah.
You can run full mode in browser, all that sort of stuff.
Yeah, it's cool. I should look more into Bcoin actually. I always say that. One day I will.
I work on it.
Yeah.
So I was kind of hoping we could see the class for that token, because that's where all the magic is happening, right? In the demo.
Yeah, my highly proprietary source code. Unfortunately, I don't want to do that right now.
So I guess then my question then is, so that's, if you're issuing this token, what's actually happening is anybody that wants to use that token has to have that file on their local database, wherever that might be.
Yeah. And the way it's going to work is they're going to find that on the blockchain, which is like always there, and just sort of plug it into the JavaScript code that's running on there. So they're going to have to download the reference implementation of the Open Token Standard, find that one little missing piece there on the blockchain, plug it into that reference implementation. And that's it.
Is there any sort of thoughts about, I don't know, like decentralizing the distribution of that standard so you can kind of like discover tokens through some sort of like peer-to-peer sharing rather than kind of like downloading it from somewhere?
I'm
just wondering like, if there's any ways that you're thinking of, because now it seems like the difficulty is actually, like right now, like anybody can discover like Bitcoin transactions, right? Like the protocol, that's basically what's in the peer-to-peer network with Bitcoin protocol. I'm wondering if there's any thoughts to like, how is there a good way to like, like they have contract explorers in Ethereum, right? Because it's all on the blockchain.
Yeah.
If there was a way to maybe have contract explorers for this, some sort of peer-to-peer distribution of those contracts of that index file.
Yeah. So that's totally something that can be built and should be built. And there's actually like an insane amount of stuff that could and should be built on top of that, right? So just like you say, like a good explorer, an exchange, just a nice website to issue this contract. So there's lots of stuff that needs to be built, and I can't build it all by myself. So I'd be very happy to get like help, and I'm still kind of determining how exactly I'm going to structure this. But certainly, I would like people to help me build this stuff together, because there's lots of beautiful stuff to be built, and I can't do it by myself. Even if I raise money, I can't do it by myself. I'd be extremely happy if people want to just help me. If they just believe in this mission and it's interesting to understand computation, be fine. Let's work together and make Bitcoin, awesome. Okay. Oh, I'm sorry. You were.
So, if I understand correctly, you're going to take a JavaScript implementation of full node. You're going to publish scripts on the blockchain. You're going to load those scripts, and you're going to run them, and they're going to have some library routines that they use to find nodes, to find UTXOs, to look at the data and balance scripts, things like that.
Yeah.
What about security? Can I write a script, publish it, and then when it runs, it attacks the system? Do you have some kind of a sandbox or some way of isolating those?
No. But it's like, look, you're downloading, code from the blockchain. Okay, you're downloading code every single day, all the time, every time you use the internet, right? Every single website has script tags. You're downloading stuff, and you're not even. So actually, my version is a little bit more secure. You're downloading from the blockchain, and that code will never change. So if you have someone sort of verify that this is a good smart contract, you can actually rely on that being there and always being good code. Okay, but nothing like this system doesn't prevent people from writing bad smart contracts, and that's just something that comes with the generality of it, right? You can, in any high-level programming language, you can write bad malicious code, right? But if you want to like do something very general, you have to sort of allow for the malicious stuff to get the good stuff.
Well, I mean, a Bitcoin script or an Ethereum script it's sandboxed, right?
Yeah.
And I think of like an example would be like Java applets. There were problems with the implementation, but the idea was you have a Java security manager that lets things run, but there's a boundary between the context of the application script and the system. And you're not planning on implementing something?
Well, so it is automatically, so it's all JavaScript implemented, and so if it runs in a web browser, it's like automatically sandboxed by the web browser, right? Like code in the web browser can't access your highlight and read and stuff like that. So whenever you run stuff in your web browser, like the average user is going to be protected by that sandbox pretty much. But then if you run this like on your service, you have to look up.
But I mean, like one smart contract could possibly interfere with another or with the operation of the node itself because they're running in the context of that node implementation, right?
Okay, so this is the question of sandboxing. Like, so I have, like, say, a token wallet, and I'm using 3 different tokens, and you're worried about like one token messing with the other token. Yeah. So of course, in my prototype, there's nothing like that, but that's also one of the things that should be worried about in the future. Yeah. Good point.
So you have plans to address that?
Yeah. Yeah.
What does a phone wallet maker have to support the tokens?
A phone wallet maker.
So someone who, Bitcoin.com or Handcash, what do they do to support?
Yeah, well, they can just use my software. Okay, it's going to be like licensing needs to be figured out, but it's just going to be like an NPM package. You plug it into your code, and it's going to be exactly the stuff that I did here in the demo. It's going to be extremely easy to use. Okay, so actually on my badly worded website, bitcointoken.com, you can see how easy it's going to be to integrate this just to use my software. So if you want to issue a new token, like out of some app or whatever, you just run a couple of lines of JavaScript code and you can issue it out there. So trying to like get all the complexity inside of my NPM packet and provide this very, very nice, clean interface that's going to make it very, very easy to use.
And then let's say a user receives an airdrop, so a token that they don't know they're going to be missing it. Is there anything that they need to do, or is it like Bitcoin.com or Handcash's responsibility to recognize that token and show it?
Well, I'm just going to have to say this is all stuff that needs to be worked out. Yeah, so I'm currently just working on sort of the base protocol, and like as soon as you start building more stuff, there's going to be like more issues popping up, and there's like tons of stuff that needs to be taken care of. And I also like you raise things that I will not come up with. So I would really like to have like a community of people who tell me what I'm missing out on.
So just to make sure I understand, in a blockchain like Ethereum, there is the miners are the ones who run the calculation. So there is an immutable state on the blockchain of all the storage and whatever the smart contracts hold. In this case, it's not, of course, on the blockchain. So it basically relies on the fact that the implementation is correct and synchronous across all codes, right? Like if there are some bugs or changes between versions or anything that causes the computation in one place to be different than another, you don't currently have a protection against that, right?
Yes, that's true, but I also think the situation is just like when you use any Bitcoin implementation, right? So first of all, the difference is like just like in Bitcoin and its tokens, the entire state is stored on the blockchain, and it's just like the sort of the computation. There can be different implementations for using.
But here, the entire state is not stored on the blockchain. You don't have really an immutable state of all the stuff that you let to a smart contract, right? There's no miner setting like the irrevocable history of the world after 6 confirmation. It's stored in theory, like you could even introduce updates to an implementation, and in theory they could even introduce new subtle bugs or changes to stuff that was already stored.
Yeah. So you're saying the problem is that like my approach, you can't update the smart contract. Is that the question?
No, more. I'm just trying to understand if there is something inherent now in the future that would provide that sort of immutability that one would want or expect in a smart contract, right? Because you want, like we use Ethereum, something similar. You have the immutability of the blockchain to back you up for whatever was the case, even if it was about right? But here you basically rely on the limitation across all nodes to produce consistent results now and in the future. As versions update, as bugs can potentially be introduced, there can be slight variations between different places. And it introduce slight bugs or like a very, very strange issue, including, of course, room for attacks. I'm just trying to understand.
Yeah. So we should talk later as well, because I might not understand entirely correctly, but sort of the way it works is like the smart contract is stored immutable on the blockchain. Okay, but then you have sort of the reference client, which is not at all stored on the blockchain. Okay, that's just software, and that can be buggy, and it's bad if it's buggy, and I have to better watch out that it's not buggy. But if I understand it correctly, I think the situation is the same in Bitcoin. Okay, so you can use a Bitcoin implementation that has a bug, and you're going to lose your money or something like this, right? You click, I want to send, 10 cents to someone. Bitcoin implementation sends 10 Bitcoin. If the implementation has a bug, there's
even if there is a bug, there would be one state on the blockchain. Like if your Bitcoin implementation is buggy and you send it to one address and you put in another address and send it to your money there, it's going to be an immutable history of the blockchain. It's still going to be agreed upon by everyone. even if it was a bug.
That's not true with Bitcoin. You can have a bug that introduces a fork. And if the buggy implementation and the non-buggy implementation will have different balances, right?
Yeah, but still you will have an immutable state of the blockchain.
But now you have two immutable states, right?
Right.
So he has the same issue, but it's. By the way, I'm from Omni Foundation, so I've dealt with some of these issues.
Okay.
It's so you don't have consensus enforced, but you can have multiple implementations that
Right, but
that have different balances.
well, not exactly, because when a fork happens, ultimately you know that a fork has happened. If you have an engine across, or engines, like smart contract engines across countless nodes, and maybe there are slight variations, different implementations, and some of them produce slightly different results. Maybe it's a result even of an attack or whatever. You don't have a way to know that. There's no fork in the chain. There's no immutable state to look at it and see, oh, look, this is wrong. There's nothing like that.
No,
The
so
immutable state is immutable because it's all in UTXOs.
yeah, all the
it's
tokens.
it's just the calculations that you run on top of that can get different values.
But everything that has ever happened, every token transfer, even if it's a wrong token transfer, everything's always on chain and like stored there immutably. So if there's a bug in one implementation, it's going to broadcast these bad transactions that all send to the wrong address or the wrong amount or whatever. That might happen, but it's going to be recorded on the blockchain. Just if you use a buggy Bitcoin implementation that sort of builds the wrong transactions, it's also going to do the wrong thing, but it's going to be like stored on the blockchain.
Yeah. Okay, I don't want to hijack the discussion. I think this point.
Yeah, I'm looking related to the talk. Just wondering, so is this, my understanding, is this another proposal of implement tokens on Bitcoin?
Yep.
So how does this differ from other kind of proposals like wormhole based on Omni or like Countercoin or Group? What are the pros and cons? It's all best in FS there?
It's just way better. No, okay. So I mean, okay, let's see here. So,
Yeah, succinctly.
okay, so I mean, the difference is that like my standard is very, very simple, and in that it's like easy to understand, easy to implement, but at the same time it's extremely expressive. Okay, you can create potentially all possible smart contracts in this state, whereas sort of existing implementations are very, very complicated, very long, hard to read, and only cover like a handful of use cases. My standard is very, very simple, covers all use cases pretty much, so it is much more simple.
As I understand it, one, you're using JavaScript for the contract language, and two, you're moving the definitions into UTXO fields instead of the OP return.
Yeah, so what I'm kind of doing is I'm moving the definition of what's a valid transfer from the standards document, sort of first step into code, and second step, I'm storing that code on the blockchain. That's the difference.
And then how is it getting stored on the blockchain? That's the part I missed.
Yeah, it's just like just in an output, just in plain text.
Okay.
Yeah.
Got it.
Yeah. So that's
So then there's a limit in the number of characters you can have in your...
Yeah, and like as overall as just the block size, and then all you just do is just come up with some way of linking to another contract. Sure. Okay, so once someone has stored their ERC20 token, in some output, you'll be able to just say, okay, just a link. I mean this contract. So we just add links there, and that takes care of it.
Good.
So the unspent transactions are checked at the client, or it seems like what you're doing when a double spend occurs, you could potentially send the same amount of coins twice or tokens twice, but the verification will not happen on the blockchain.
Yeah. So if a double spend occurs, probably what could happen is that a transfer switches from being valid to invalid. Okay, so maybe so you're talking about like a normal Bitcoin double spend, right? Token double spend. Well, token double spends, they can happen, and they will be recorded on the blockchain, and everybody will be able to check that this was an actual double spend, and not accept these tokens. This is nothing that I invented. This is something that's been there in the So one important thing is I'm not inventing any new sort of security model here, okay? I'm choosing exactly security model of color coins that has been battle tested to $2.5 billion valuation. Okay, all that I'm doing is I'm using it slightly and sort of exploiting it a little bit more, and this is where I get my exclusivity.
I wanted to transfer Bitcoin instead of tokens and obey the rules in JavaScript. How would that work?
Well, if your token standard permits that, you know, maybe, I mean, that's a very good use case. This is how you trade tokens, right? It's like I send you a token, the same transaction, you send me money, and you just if sort of sort of this little JavaScript file that's provided by the token issuer supports that, then you can do that. Yeah, you can define a token standard that has no data at all. That just says you can only send even amounts of Bitcoin. Okay, whatever.
We have time for one more question.
Okay.
So here you're doing on-chain transactions for everything.
I'm sorry.
Here in this model, you're doing on-chain transactions for everything.
Yeah.
As you know, transactions with tokens on Ethereum are cheaper, so there's a lot of activity there, and Bitcoin is tracking the Lightning Network, etc. to minimize these on-chain transactions. So do you see this model adapting to a Lightning model in some form down the road, or does this always have to be on-chain?
Okay, so currently, as for the price point, I'm just as concerned about the prices as you are, and that's why I'm targeting Bitcoin Cash. Okay, so the few investors that I pitched this to was I was like, I can do everything in Ethereum just 100 times cheaper. Okay, because I can do it on Bitcoin Cash. That kind of resonates. If I were to do this on Bitcoin, I can do everything we can do in Ethereum just 100 times more expensive. No, it's hard to get funding that way. Okay, so but then all sorts of tech can be built there. Okay, and then again, an interesting question. So I really think there's like an infinite amount of like almost research that can be done in this field, and can be adapted to whatever.
Let's give Clemens another round of